Good day, everyone. This is Kevin Michelson with the Central Florida Tech Grove, and welcome to our next installment of our Tech Connect webinar series around vIITSEC best papers. Today, our topic is coming to us from the Policy Standards Management and Acquisition submission, and it is coming to us from the team from the United States Marine Corps and John Hopkins Applied Physics Laboratory, doing research and studies on return on investment around live virtual constructive training. This was a very interesting paper to me as being selected because I think it really speaks to us in the end of how do we justify the purchase, the use, and sustainment around LVC going into the future. And so this team has done quite a bit of work for the Marine Corps in justifying how and where to best apply LVC over both the short term and the longer term, and doing it through a model that I think everyone on the call today will take a look at and say, hey, this is really important for us to look at, and how can we adopt this similar type of model going forward. So with us on the call today is Jeff Bergenthal, Bill Probst, Captain Garrett Loffelman, and Rodney Yeager from the team. And on the call with me today also is Tim Welch, who is our co-host, and Tim and I will be monitoring the questions and chats on the back end of the presentation. So first of all, if you're free to commune and talk with each other on the chat line, but if you have a specific question that you would like to ask the team based on the information that you're hearing, please put it into the question and answer side, because that's where we're going to be monitoring and looking for the questions that you want us to ask on your behalf back to the team. The nice thing is you guys have been really proactive, and we've already received quite a few questions. So that tells me that you've read the paper, you're pretty excited about this, and as I am as well, because this is one of those unique papers where we're not just talking about technology, we're talking about the benefits and showcasing why there's a return on investment. And it's often a topic that doesn't get covered, but I think it's very relevant to us going forward as we develop these new technologies. So Jeff, without further ado, I'm going to turn it over to you, sir, to introduce the team and kick us off.
All right. Hey, thanks, Kevin, and thank you everyone for joining us in the call. So with me today is, I guess first I'll introduce Captain Garrett Loffelman. He's with the Marine Corps, the Training and Education Command. He was our government liaison for this study, and the person that we worked with on a day-to-day basis as we performed the study. Also on the call is Dr. Bill Probst, who was our study lead. Bill's been doing tons of work in training and readiness and training effectiveness throughout his career. And Rodney Yeager, who leads up our cost analysis group at the laboratory, who really focused in on the analytic approaches that we use to not only do the economic assessments of live virtual and constructive training, but also to pull together the non-economic assessments and bring it all together into a good framework. So with that, why don't we move on over to the slides? So we've got a small number of slides that the team is gonna talk through. And first I'm gonna kind of talk about what the outcomes of the study were, and then I'm gonna turn it over to the rest of the team to walk you through the approach that we took to perform the study and the data that was captured, the types of calculations that we did, and then finally walk through, I guess we can call it some of the aha moments. What are the takeaways for you as an audience on the work that we did, and how to interact with the services about live virtual constructive training. Okay, so with that, let's see. So what were the key outcomes of the study? So, we developed what we think is a robust and repeatable methodology that can be used to quantify what the future return on investment of live virtual constructive training is. As we started the study, we went back and looked at probably 24 different studies and analysis that have been done on trying to determine the return on simulation and modeling and live virtual and constructive and training in general. And as we looked at those and looked at them in the light of how the Marine Corps wants to use live virtual and constructive training for training company operations, battalion operations, and staff level exercises at the Marine Expeditionary Unit, Marine Expeditionary Force level, we found that there really was not a good body of metrics that you could use to try and figure out how live virtual constructive is providing benefits. So we took an approach of combining traditional economic viability metrics, so things like life cycle cost estimates, net present value, break-even point, return on investment, along with 13 different metrics that the team developed that are really focused on trying to understand how readiness may be improved and how training can become more efficient. Can you get better and learn your skills more quickly? Can you retain those skills longer? So a combination of economic metrics as well as readiness and training efficiency metrics. When you pull all of this together, you're providing a lot more information to senior leaders and decision makers that enables them to start comparing and start evaluating the whole cost readiness trade space. So as we did the study and presented the results to the leaders, we looked at 4 different cases of live virtual and constructive that cost a different amount of money and have different impacts on readiness. And so that was a pretty decent sized trade space for them to evaluate, and more cases could be looked at using this methodology pretty easily. In April of 2020, we concluded the study and we presented the results to the commanding generals of the Marine Corps Training and Education Command and Marine Corps Systems Command. And we showed them through the analysis and the cases that we looked at that significant readiness and training efficiency improvements can be achieved by using live virtual constructive training. And the amount of improvements vary depending upon the types of LVC that were used. And so again, it gave them a decision space that they could look at and try to decide what types of resources they were going to apply. Throughout the study, we found that there were areas in which data that you need to determine readiness improvements and even to determine what the cost of training is were kind of lacking. And so we recommended that a data strategy be developed to capture that data so that the Marine Corps can, better understand how training is improving readiness and what the true cost of training is. And Captain Loffman can talk about, how the Marine Corps is actually implementing that now. And then finally, the Marine Corps, based on the results of this study, is allocating and spending some research and development funds now to take some of their existing training capabilities and federate them as a first step in the live virtual constructive training environment. So with that, I'm going to turn it over to Captain Loffman, who will talk about the need for LVC.
Hey, good morning, everybody. So what I want to highlight on this slide is I want to talk through the specific problem space that live virtual constructive simulation technologies are really targeting. So I want to talk through what is the issue with really modern day training. And I would say that these issues cut across a variety of Defense Department organizations. However, you could make an argument that certain organizations are further along in trying to solve some of these problems, but let's kind of go through this a little bit. So when we talk about live training, typically live training lacks the realism required to really get the most benefit out of the high cost of live training. What do I mean by that is even though we try very hard, especially in the Marine Corps out in 29 Palms and in other venues to mitigate training isms, there are always safety concerns that are going to take that training environment away from the realistic execution. And typically, those are the biggest issues within the live environment, right? Is, for me to go from mortars down to machine guns down to small arms, basically working through that conditions met criteria is going to cause some safety requirements that make the training less realistic. And also, as you have to pause training or restart training as a result of safety violations, that also starts to take away from the realism. However, on the flip side, live training is one of the few places in certain environments where we can start to integrate a variety of different stakeholders from the MAGTAF. So you can start to integrate your air assets with your ground assets and so forth. Now, in the simulation domain, we often lack the multi-domain fidelity, as it says there, or the ability to bring these disparate communities together to train on a common operating picture. Instead, what we have are pilots inside of flight sims and Marines, on the ground, and let's say a fire support team inside of a supporting arms virtual trainer or SAVT, training team or individual level skills and bringing those skills together that maximize everyone's training benefit is often a challenge. Furthermore, battalion and below units, they do use simulation for those individual skills, but getting that combined arms training experience that really integrates warfighting functions is incredibly difficult in the simulation environment if you don't have good interoperable networks. So as we've started to look at this problem, basically what we've found, especially in light of the 38th Commandant's planning guidance and Force Design 2030 implications, is that as we move towards a distributed, navally integrated fight, the requirement for more repetitions for decision makers working with multiple agencies has increased significantly. And this puts further demand on a live virtual constructive training environment capability that allows Marines to not only train together as a MAGTAF, integrated warfighting functions, but also train as a part of the joint community. And as some will say, we've been able to do this in the past through a variety of kludged together networks or in a constructive realm, but doing it across the live, virtual, and constructive training domains to maximize the training efficacy for all of the different players is something that has been very challenging for us to get across. And not only has it been challenging, but it's really been it's been a hindrance on the ability for the Marine Corps to maintain readiness and proficiency across these skills. So, only a couple battalions a year go to the integrated training exercise and get that experience of aggregating as a MAGTAF. And once again, as we move towards distributed operations in the Pacific, the cost prohibitive nature of bringing people together to do that makes those opportunities even fewer and far between. So providing an infrastructure to facilitate that becomes rapidly important. Slide. All right, so where does the Marine Corps really see the live virtual constructive training environment? Well, we see it as a dedicated training network that really provides the infrastructure for a variety of standalone programs to plug into that network and provide an integrated training solution. You can see the example vignette that's down there, and that speaks to some of the force design operating concepts that are the Marine Corps would like to train moving forward and increase the proficiency of the Marines. But as we'll talk about at the end of this slide deck, and why I think this study was largely a success and well received by the Marine Corps, was really it's all about being able to integrate the technology with the readiness impacts. And if you can't start to define what those readiness impacts are and how the experience inside of the simulation environment, it's very difficult to demonstrate that the system or the family of systems is having a positive impact on the service. Typical return on investment studies that have focused purely on cost or cost avoidance typically don't do very well because, as an example, I can go inside of an indoor simulated marksmanship trainer or the ISMET and shoot 100,000 rounds just pointing the weapon at the screen, and I may not be getting any actual educational benefit or practical benefit out of doing that. And as a result, those rounds are not representative of any actual return or any gain on the investment in that system. So if you're not tying those readiness benefits to the savings or of cost avoidance that are being achieved by using the systems, you're not really capturing a true return for the service. So as we move towards like I said, a dedicated training network, and we'll talk a little bit, the Marine Corps is interested in basically a multi-increment strategy that was decided prior to us doing this return on investment study during the analysis of alternatives. And the reason that we're moving towards an incremental approach is because we believe that this is a pretty monumental shift in the way that the Marine Corps currently trains. And therefore, increment one really provides the infrastructure and the network lay down to integrate these systems, better understand the requirement for simulation, and start to shift the culture of the Marine Corps to provide more sets and reps inside of a simulated space, and being able to integrate that in a progressive manner across your battalion's workup life cycle. That will help us better define the requirement to then develop a more holistic solution of integrated systems as a part of LVC-TE Increment 2. So I think that's a good overview of where we are today and where we kind of want to go. And I'll hand it back over to Jeff and his team to talk about kind of how we went through the study.
All right, over to you, Bill.
Okay, so let's talk a little bit about data collection for the study. And that really was on, as Jeff said earlier, 7 scenarios from the original analysis of alternatives. And those were collective training events from company ops up through mess staff training events. So we're not considering the entirety of Marine Corps training, we're just focusing on those 7 scenarios. We only focused on active duty forces, we didn't look at the reserves, but we did look across all 3 MEFs. And for each scenario, we identified a number of operational modes using live, synthetic, or LVC formats to enhance the training. And as Captain Luffelman said, we considered a number of tech instantations in the analysis. The status quo is training events today. Formats they're using. Increment 1 is an evolved training event in a near-term bridging training environment. Increment 2 then was an evolved training event in a new build, longer-term solution training environment. And then we also considered an excursion with Increment 2, where that same new build was slightly reduced live training events. One of our assumptions going in from the air carried from the airway was that live training would not be reduced. New training events would add synthetic and enhance live events, but we would keep the amount of live training the same. But for the excursion, what we did is reduced it slightly while increasing the number of synthetic events. On the left-hand side of this slide, you can see some of the empirical data sources we had. Cost data, really the C2RAM program provided a lot of information. Rodney can talk more about the government cost data he was able to access. Subject matter experts, we traveled around the world. We did Quantico, Camp Lejeune, Camp Pendleton, 29 Palms, Marine Corps Base Hawaii, and Okinawa. At each site, we sent a team of people, 3 to 4 people. We talked to whoever was available at the swim centers, units that take part in the training, who were gracious enough to give us their time. And we ultimately got 120 participants across every major organization to give us very detailed feedback. We talked to a lot more than that, but we got 120 to actually give us highly detailed feedback. That allowed refinement and ranking of the ROI metrics. That was something that we had a literature review that on synthetic training metrics, but talking to the Marines, we're able to refine those and rank them a lot better. And then in the training data, what we could pick up from remotely, either teach, training, exercise, and employment plans, exercise schedules and manpower requirements, but at the same time also going out talking to folks to understand what were the things they were doing, why were they doing them, or what are the things that they weren't necessarily writing down along the way. Was invaluable to understand kind of how the pieces fit together. Right-hand side really is a utility curve. When we started collecting raw data, we used the utility curves to convert them into value scores. And that was this is one example along the way. So collected a lot of raw data, converted it over to value data. Next slide, please. And this really lists, and it's an eye chart, but all the set of metrics we used, we had them in kind of 3 big bins on the left-hand side: increased effectiveness on the operational battlefield, high risk, low opportunity training, and improved effectiveness and efficiency of training events. And based on the feedback we got from the operating forces and the training commands, we were able to rank these based on their perception, their understanding of the relative importance of these. And Rodney can go into greater detail on that.
Okay, thanks, Bill. This is Rodney Yerger. I'll just say a couple more things on this slide before we go to the next slide, and that is that, the next slide is going to show notional results of how this all comes together. So this slide here is showing, of course, like it says, the non-financial metrics used. There's 13 of them under three major buckets, right? The three big buckets you see there under the criteria column. The results you see here are simply the weights, like Bill said, of the operating forces that we got their inputs from. And what Bill said on the prior slide to that was, we used utility curve analysis to convert raw data to scores. So this, when you have now what in a sense is called a unitless value, right? You have a value from 0 to 1, and then that's influenced by these weights. It allows for the ability to roll up overall scores for these three big buckets. So hope that's not terribly confusing, but the bottom line is that your weighting criteria in order, and those weights are influencing the scores of these non-financial metrics. So if we can go to the next slide, I can show this all comes together. So these are notional results, but this is what you would typically see in a economic viability analysis, where you're looking at both financial and non-financial gain or benefit. Okay, and as Captain Loffelman said, it's incredibly important for government related economic viability assessments to include non-financial. So I think this was one of the questions I had previewed from the crowd, but do we monetize benefits? Okay, so the answer is in most cases, no. Like I don't have the ability to monetize, or I wouldn't want to try to monetize a metric like increasing combat readiness. In the private sector, of course, that's much easier to do because they work with things like profit. But in this case, it's clearer to have a breakout between non-financial and financial. So I haven't spoken much about the financial side, and I'll do so very briefly. To be able to calculate financial economic viability, we had to set out to cost out a status quo, okay, which was not really there. It was a very involved effort. As Bill said, we used the cost to run a math database where we were able to take representative exercises for the 7 scenarios we used and their operational modes for various locations. We were able to come up with a status quo estimate of what it costs to do the training as it's being conducted presently. And so you'll see in the fourth column under the financial bucket, life cycle costs, we set out to basically calculate life cycle costs, which those of you that may not be familiar with that term, that means we're looking at all life cycle phases to include research and development, procurement, operations and support costs, or what's commonly referred to as sustainment costs. And that's going over a time horizon you see there on the slide. And so that adds up to the overall cost of each alternative. So we were able to, once we had a status quo, now we were able to cost out the 3 other alternatives, which Bill mentioned, increment 1, increment 2, and increment 2 excursion. And you can see their costs under that column of life cycle costs. And then really just briefly to walk through financial, these financial metrics, these are commonly done in economic viability assessments. ROI would be basically taking the difference between the year-to-year costs or savings from the increment 1 to status quo, for example, and then dividing those year-to-year savings or costs divided by the actual investment of the LVC that's going on in increment 1. And of course, the same would be done for increment 2 and increment 2 excursion. So then you basically get a percentage, right, a return on investment, and anything greater than 1 would be technically considered economically viable. Net present value is somewhat similar, except you're not dividing by the initial investment. You're just literally taking the year-to-year savings that you would be accruing over the duration of the effort. and you are then basically subtracting increment 1 costs minus status quo costs, for example, and you then discount that back to the present year. That's why it's called present value, net present value, because you're basically taking into account the time value of money, so that you understand what today's dollars is, what you're saving in terms of today's dollars. So when I show a net present value there of 3,701 million for increment 1, that means that's basically the time value of money adjusted savings you're getting from increment 1, break even then is when I have my initial investments. I'm obviously, if I were to show this in a time series, I'm investing. It's almost always the case that there's going to be an investment involved with one of these alternatives, and therefore you're going to go into the red over time, right? I'm going to be spending money, and then I start accruing savings. So the break-even point tells you at what point do you start generating overall or net savings. And you can see with increment 1, we're generating savings very, very soon into the effort. Increment 2 excursion, we're generating it much later. Increment 2, we're not generating it at all. So very briefly, to tie up this financial piece here, these were calculated based on doing these cost estimates, okay? The main drivers, which would be of most interest, how are these numbers being calculated, or why are they resulting in these kind of results, these kind of what you see here, has mostly to do with the fact that there are estimated savings being accrued from plan preparing and assess activities. When you move to more virtual constructive training, these are basically the main reason why you're achieving reductions in increment 1. In increment 2, as Bill mentioned, you are making you're doing the full Monty, right? And you're doing all of this, and you're not reducing live training. So there is a cost to this, and so you are not generating any positive ROI or positive net present value, and you're never breaking even. I say that, I stress there, financially. Okay, and then increment 2 excursion, because you are reducing your live training, and with the idea that more synthetic training is replacing that, then you are achieving a positive financial gain there. Now, last thing I want to speak about briefly is, as promised, the right side of this table speaks to the non-financial criteria that you saw on the previous slide. So all 13 of those metrics are coming together under those 3 columns, the 3 major criteria buckets, and then you get an overall score, right, for status quo, increment 1, increment 2 excursion. So again, you have the ability to go into the drivers of this as well. You can do sensitivity analysis on the weighting to make sure there's not anything crazy going on there with weights. But suffice it to say, it's quite simply, you get an overall score. You can see that, just like the bullets say there at the bottom, increment 1 provides that slight non-financial benefit, right? It has a pretty significant ROI, but of course it's not going to generate as much non-financial benefit compared to the status quo. Increment 2 is one of these stories where you have significant benefit in the non-financial realm, but of course you're spending a lot of money to get there. And then increment 2 excursion, there's a slight drop off in the non-financial with the additional financial gain. So again, leaving you with a picture that this is an economic viability assessment. You can look at things by both financial, non-financial, this allows the decision maker to have a full array of different criteria to look at to help or influence a decision. And I think I have nothing more to say on this slide, and I can turn it back to, I believe, Captain Loffelman.
Hey, Rodney, real quick, I know we're going to get to questions at the end, but this comes up a lot. So someone's asking about if you go back to the last slide, Jeff, the 3.7, I believe it's billion, correct me if I'm wrong, net present value for increment 1. And if you could highlight that these costs are focused on like a service enterprise level cost and how we kind of came to that.
I'm sorry, Captain. When you were go ahead. Sorry.
Go ahead,
Frank.
Frank.
Speaking.
Yeah, I was just saying, there's a question in the chat, and we're gonna get to questions later, but I just think this is relevant to this slide because it comes up frequently that the numbers are so high. So if you could just highlight how these are enterprise level numbers related to training, and that's why you see that net present value of 3.7 billion.
Yeah. So again, this includes the cost of live training as well. I want to stress that, which is, across, we basically are trying to cost out the entire enterprise. That includes the trainee labor costs, right? So that the trainees going through it based on training days and total packs per the selected exercises we got out of the database. It includes the trainer labor. It includes things like ammunition, range usage, operations. That's all in the execution costs. And then, of course, there were the additional planning, preparing, and assessment costs that were added on as well. So this is a complete enterprise look for the scenarios, operational modes, and locations that were in the scope of the project. Hope that answers the question.
Hey, this is Kevin too. And I think that, again, people get lost in that this is over the longer period of time of 23 years. So this is the big picture, not just a sliver or snapshot, correct?
That's correct. And even the logic behind the 23 years, for example, that came out of the AOA that was conducted before this. But when you're looking at an alternative that's going to be implemented, and it's especially related to IT improvements and IT related type of activities, the standard rule of thumb is to take out a sustainment duration of about 15 years. So the 23 years is based on 15 plus the amount of time we were we were assuming, or the average of each of these increments were reaching like FOC. So 23 years is right around the sweet spot to do apples to apples comparisons of each of these alternatives. But yes, all the costs are, when you see a big cost like that, it's accrued over all those years.
Okay.
All right, so thanks, Rodney. I'm going to go over some conclusions that I think for our industry partners that are on the call are relevant, as well as kind of talk a little bit, and I'd rather get into the discussion sooner rather than later, because I think that's probably the most fruitful for everybody and enjoyable. But I'd like to talk about some key takeaways for the service, for the Marine Corps, and then key takeaways that I think are relevant to the industry folks who are on the call. So the first one I want to talk about is about learning analysis and the importance of the problem space. So I think oftentimes, here at TCOM, to be clear, we work as the resource and requirements sponsor. So our job is to define really end user requirements. So when we get a needs statement, like I need better JTAC training, converting that need statement into a defined requirement, validating that requirement, and then ultimately handing that over to our acquisition sponsor, who then works with you all to then generate a solution that then gets fielded and supports the Marines. I would say a general trend in the past that I think this study is tangentially related to is that we typically look for solutions that are big box solutions that support the JTAC need or the JTAC requirement. And I think one thing that we saw from the responses and the utility curves from our respondents was that it's not so much about better JTAC training, but it's doing the in-depth learning analysis to identify that perhaps it might be the correlation of the pilot on target during the 9-step process of close air support that is really the part that trainees or Marines are really struggling with. And so a lower cost, more accessible solution that specifically targets that difficulty area might be more applicable to the Marine Corps and have a larger benefit, because it's really going to be the thing that drives that increased effectiveness on the battle space while keeping the cost of that solution down. So I think, if we pull that thread through, the key is really trying to work with end users early in the development process to identify, what is it specifically that they are struggling with, and making sure that the solution isn't a one-size-fits-all high-fidelity solution that comes at a large price tag, but more specifically a targeted, potentially part-task trainer that focuses on the trouble areas of the training audience. The second point that I want to bring forward as an kind of an aha moment, and we've touched on this briefly already inside this kind of webinar, is that it's really all about readiness, and that cost reductions need to really relate to skill acquisition. And so to jump ahead a little bit to some of the questions that I saw leading into this conference, someone asked, are you capturing any data to help determine readiness? So where we're going, where the Marine Corps is going, is right now Policy and Standards Division is developing a rigorous assessment and evaluation model that is largely built on a body of research, a thesis that I was a part of at the Naval Postgraduate School on developing quantitative performance metrics across a variety of training and readiness related skills. And that would provide a more robust data set. We talked about, there was an inadequate set of training related and cost related data to really pull from. So a more robust set of training data so that we could start to look at correlations between systems that are being used, what those systems cost, and then ultimately the readiness benefits that those systems are having. And I would also add that the imperative for doing this kind of deep analysis is definitely being marshaled along by not only the DCP&R, who are the budget folks for the Marine Corps, but ultimately their masters up at the congressional level, the government accountability offices of the world, who are pushing down on the Marine Corps and requiring stricter requirements for how we're going to actually track the benefits of these, relatively expensive, ultimately cost-saving simulation technologies. And I think it's important to highlight that the real key here is if you're not tracking the readiness and training benefits, then something that we are arguing to ultimately the taxpayer that saves the service a significant amount of funding. If those readiness benefits are not being realized, then those funding, really those returns on investment, or those funding benefits, those cost savings and cost avoidance benefits, are never going to be realized because you're not using the system to gain a readiness benefit. So the Marine Corps is moving towards trying to track those readiness metrics more effectively. We have found that there are some issues. The first one being a more professional rater or train the trainer pipeline to have evaluators that are, that have been trained to be evaluators and certified to evaluate specific skill sets, and what that model looks like and how you support that from a manning perspective. I'm not going to go into that. That's not really what we do in my office. I can tell you at TCOM, who is responsible for these simulators and simulation systems, we are in the final stages of drafting a Marine Corps Order 3550.14 that is outlining the policies and procedures for ground synthetic training systems. And in that Marine Corps Order, there is a section on how to properly evaluate simulation programs. And what we say in there is we start with the systems, we start with the forecasted demand of the system that is based on the training and readiness requirements. So inside of the TNR manual, there's a linkage between these systems and the TNR themselves. And just to connect this back to the study real quick, because I don't want to seem like I'm going off on a tangent. This is the connection between the study. We were forecasting the return on investment of live virtual constructive training environment technology and simulators in general. And now I'm kind of highlighting and walking through what the service is doing to basically validate those results and build the data model so we can go back and say, are we actually achieving this forecasted return on investment? So the way we'd like to do that is by capturing the utilization of these systems. And then we're comparing that not to the available training days, but we're comparing that to the expected utilization based on the TNR training and readiness requirement. And by doing that, we're saying, okay, there's, we expect 6,300 training days inside a deployable virtual training environment to be used based on these TNR requirements. And what we will find, and what I believe we'll find quickly, is that the TNR is missing some linkages to these simulation systems that often leads to underutilization and some other pitfalls. And that will drive a feedback mechanism to essentially better capture the training requirements for where we integrate and don't integrate these systems. And that will drive the Marine Corps to better integrate live virtual constructive training technologies moving forward, capture the relevant readiness data, and then the last piece of the equation is really capturing the cost data. And as Rodney and Bill and Jeff all pointed out, there's been a lot of work in that area, working with the supply and G8 communities around the Marine Corps. But there are some pitfalls as well, and there are holes and issues with that costing data that really need to be solved if you wanted to get to a completely robust and transparent, almost business-like, income statement approach to how much are we using these things, how much are we losing on these things, and how much are we gaining. So that's kind of an overview with some highlighting how to validate these results and really determine current return on investment benefits for these systems. But it's really all about building the data model, which we've outlined in the order, and then restructuring not only organizations, but also the IT infrastructure behind POM and during other resource-based decisions. So that's all I have. Thank you.
All right, back to you, Kevin.
Great. Guys, this is a very large, complex task that you undertook in terms of doing this study, and I think it's something that was long overdue in trying to analyze this. And I think when we were talking about how do we present this, I think you did a fantastic job of talking about the big outcomes and then drilling down to why it's important to industry. So there are a number of questions that came in earlier, and also I've seen here, but I want to ask you, so this is for large scale, and for industry guys that are developing particular solutions or plugins to existing STE or LVC applications. Can this model be used to help them have that discussion with their customers? So the other service branches, when they're looking at developing and then saying, this is the value, this is the proposition that we bring, and this is the savings and the readiness that we're willing to stake our reputation on, and here's the model behind it. So can you speak to that? And then a follow-up question on that is, can you create a configurator or some form of application that takes some of those models and metrics that they can use and standardize that across some of these, so that our industry peers are looking apples to apples, and it's not my configurator versus Tim's configurator versus Joe O'Connell's configurator, right? So that's what we're kind of looking for there.
Okay, let's see. So I guess I can start off on that. So I think this approach can be used quite broadly. The economic viability approach is pretty standard, and that's not going to change from service to service. I mean, you're going to have to get the different data from the services, but the approach and how you develop life cycle cost estimates or calculate net present value is not going to change. I think what will be different is, some of the specific values, what is important to the Air Force, say, as opposed to what's important to the Marine Corps. The types of things that may have to be represented in order to be able to train for the high-end fight could be different, and the values or importance that the stakeholders place on some of the aspects will be different. So that's where it's going to be important, especially as Captain Laughlin was saying, is to have those interactions with the services, not only the acquisition branch and the requirement setters, but the actual operational forces, and understand where they see the gaps, what they think is most important, and take that data into account. And once you have that data, then you can put it into, follow the same sort of approach that we use.
But as far as like a standardized configurator where you can manipulate some of these values and maybe adjust the percentage values or those types of, or influencing, there's no real solid online tool or spreadsheet that could really replicate the work that you've done at this point.
That's probably true. I mean, once we figured out what the metrics were, Rodney and his team used, and correct me if I'm wrong, Rodney, but I think he used Expert Choice which is a commercial off the shelf package.
Okay.
That helps you do the analytical hierarchy process and MCDA, and I have to get a dig in on one of my friends. Of course, if Joe O'Connell builds a configurator, it's going to be the best one out there.
Okay. Hey, Tim, I know you've been watching some of the chat and the questions. I was going to turn it over to you for a couple.
Yeah, I was going to, Mark Lucas asking the Q&A, what was lacking from the LVCT from the study? What gaps were identified that still need to be addressed by technology or procedures to enhance realism?
Yeah, so I think I answered partially in the chat. I mean, I think one of the biggest gap areas we found is the effects of operating in a contested cyber environment, a contested EW environment, and a contested space environment. Training without GPS, training without comms is not something that's done. And how do you represent that and represent it well in a synthetic environment, a constructive environment, even a live environment is kind of lacking. So that's one. Captain Laughlin, other areas you remember?
Yeah, so I can talk to some areas we're actively examining now. So one really tough problem to solve is what we call, and you may be familiar with the term, cyber for others. So we've done a lot of work, the Marine Corps, as well as all the services have done a lot of work on kind of developing what are called cyber ranges. So think of a kind of a sandbox where cyber Marines and cyber soldiers can get together and defend networks, attack networks. But how do you pipe the effects of that over into a larger training exercise and integrate it is very challenging, because if you let the cyber Marines, let's say, attack the network itself, it often disrupts the entire training exercise and reduces the training value. So what you really need to do is think about it in two bins of, I need to do cyber for the cyber Marines, and then how do I take those effects and provide them to decision makers or people on the ground who need them at the right place and appropriate time to drive training. And that's a part of I think that's a good thing to transition a little bit, a part of a larger kind of trend that TCOM is focused on, and that's really on managing training programs with an acquisition tail rather than managing acquisition programs with a training tail. And just to highlight what I mean by that a little bit is we're trying to get back to doing an in-depth learning analysis, which I talked about a little bit on the front end. What are we really trying to teach? And then these technologies serve as methods and media to really support the learning. But what has been, I think, done potentially, you could argue, was done poorly in the past is let's acquire this piece of gear because we're going to then figure out how that can help JTACs moving forward, or does it have the fidelity to support, rather than really starting with the end user in mind and thinking about, okay, maybe it's a mix of some classroom, some low fidelity simulator, then we go to a high fidelity simulator, and how do we employ that in a progressive model building towards increased skill proficiency? And that's really where we want to go. And like I said, that's about managing a training program holistically and not acquiring a gear pile.
So with some of these gaps, to follow up on that, are you able to use this model or process to create like a predictive costing? So you can, present, in order to do this, this is the best way forward, and here's how much it's going to cost, and here's how much you're going to save if you go with this route.
So we, again, based on the call it the level of importance that we got from the stakeholders, we can identify easily whether filling, what type of impact on readiness and training efficiency filling those gaps is going to have. I think it still is going to require some engineering estimates to, engineers getting together to figure out, okay, what's it going to take to actually build a capability that can provide, reasonable cyber for others within an LVC environment. And then once we understand what those costs would be, then that can get plugged into the model and you can understand the cost benefit.
So let me follow up on that. Go ahead, Kevin.
Sorry, Kevin. Just to pile on a little bit, I think that I put in that last slide. I think the key is testing. It's testing early and testing often, because what we're trying to do is develop a relative cost profile for units that do use these things and don't use these things. So imagine, if I'm doing everything live, then I'm spending a lot more on JP8, on maintenance, on travel, right? So then the question is, how much readiness am I getting as a result of spending those resources? And if I look at that compared to, let's say, another unit that used a ton of simulation, but I can see that they had equal or, like relatively similar readiness benefits, then basically their cost per point of readiness comes significantly down. And that's when I start to, I would argue, realize those those returns. Right now, what I would see is like unrealized returns, and now I move to being able to kind of realize those returns. I think projecting these on new technologies that are going to meet those gaps becomes difficult if you can't assess. Once again, it's all back to the training. If you can't assess how Marines are going to respond to the new technology or device, and when I say respond, does it really meet their training requirements? You're going to see that skill improvement. So I think a model that probably makes sense moving forward, and something that we're working with PM Traces down in Orlando to do, is develop a prototype relatively quickly, get it in front of Marines, identify pain, and this is nothing new. This is agile methodology, but define pain points, understand how they're, run some very simple user evaluations, training effectiveness evaluations on the front end, identify what they're doing well, where pain points are, rapidly improve it, do it again, and do it in an iterative process rather than let's try to get this monolithic requirements documents perfect on the front and then spit out a solution, 4 years down the road, and only to realize it's not really meeting the human training requirements.
Yeah, so let me pile onto that, because I think there's an underlying of what you're tracking for the readiness, and I think that came out in the model where you were having to simulate what the final readiness would be, and a lot of that was because you didn't have enough of the raw data to make that determination. But it's like Internet of Things. We can collect tens of thousands of points of data on every single soldier, Marine, airman, etc. What is that barrier to entry to collecting enough information to be relevant, but not overwhelming the system that it's just too much data and it doesn't help meaningfully make the model better? And I'm just kind of struggling with that. And I think that's one of the barriers to entry. And maybe there's some folks that are on the call that are mathematicians or training experts that can help us solve that. These are markers that we need to track and effectively put these into our training devices so that you're getting better data to make the model better. What are your thoughts on that?
Yeah, so I think one of the first things we identified is that just some really basic information is kind of lacking. So when a unit goes to one of the simulation centers and they start using the simulation devices, or even if they go to a range and start using a range, there's information that they went there on a particular day and what unit it was, but there's no information about what training and readiness events they tried to train, what missions they were trying to train for, and what the outcomes of the training were. Did they successfully, complete these training and readiness events, and what were their scores? So even just capturing that type of basic information is going to be tremendously beneficial.
Is there a standardized format for that?
Garrett, are you guys working on developing a standard for that now?
Yeah, so I touched on this, and I don't want to plug my own research, but so
why not?
Carter, who was So Colonel Harder, who was my previous boss and was the synthetic training integration management branch head at RTPD, he contacted me while I was at the Naval Postgraduate School getting my master's in modeling and simulation, and basically threw out this problem of how do you measure integrated training system benefits? And that's kind of related, right, to what we did for this study. And after doing some pretty significant research into how you do that and trying to come up with different ways of doing that, what I found was it's really hard to do it accurately if you don't quantitatively measure skill proficiency. So if you don't the analogy I use is, I like to talk about Moneyball a lot. Moneyball only works because we defined the rules of baseball, i.e. if I hit the ball over the fence, it's a home run. And if I get around the bases, I can look at, okay, what are the things that are correlated to getting more points? Is it people getting on base? What is it, right? And then I can optimize the baseball team to meet those requirements. Well, what I would say is the Marine Corps really needs to define the rules of baseball before, and I would say all the services need to define the rules of the baseball game before we can do a really good, robust job of optimizing for those benefits. And so what I argued in my research was basically to develop what are called behaviorally anchored rating scales, BARs, that sit on top of the training and readiness manual, and then provide a robust training to evaluators, and then to calibrate them, and then look at the reliability. We looked at the reliability and accuracy of those, what are really subjective subject matter expert opinions of, let's say, a squad attack, and then see if those opinions are reliable and accurate enough to be used to make decisions. And what we found in my small study was that they are relatively accurate and reliable. However, there's been a recent follow-on study that TCOM has ran as proof of concept of basically my thesis on SPEMS. And what they found was that the reliability, as they went to broader tasks and larger tasks, started to fall. And they didn't think that the findings was basically, it had nothing to do with the scale itself, but there wasn't enough calibration of the raters. And that's why I mentioned earlier, we're looking at a more robust train-the-trainer evaluator criteria. If you look at the aviation community, for any of our aviators on the line, they have a weapons tactics instructor requirement at WTI. You go through WTI, then you basically get to be a trainer, and you've gone through a more robust kind of certification to be able to train, assess your pilots in your squadron on their various skill sets. So right now, TCOM is basically moving through an overhaul of how we can best do that, and then how we put in place an assessment and evaluation framework that takes into account both the quantitative side, or the technical execution of a task, with the qualitative side, which is, once again, I'll wrap up with this to not be long-winded, but if you think about an attack, and you'll say you're going to do an action left on an enemy defense, you can kind of screw it up in two ways. You can either not look at the enemy defense at all. People hear about this in the art and science of warfare. And you do a perfect action left, but you don't look at the defense, and you go right into the teeth of the defense, and everybody dies. Or on the flip side, you do a good job of cognitive decision making. You look at the defense, you understand that their whole defense is oriented on the left side, so you go to the right. But your technical execution of the event is so terrible that the enemy reorients their entire defense before you get there, and everybody dies that way too. So there's a mix between your basically technical execution, your TNR skill execution, and then your kind of cognitive decision-making. And so right now we're in the process of working with the Office of Naval Research on a project called the Streamlined After-Action Review Tool Visualization. And the entire first phase of that is about defining the data model that basically integrates these various assessment points to build a robust, really it comes down to defensible way of assessing, the execution of these tasks that can be applied broadly.
Awesome. Hey, you know what? We could probably talk for hours going on this. This is a great subject, and it kind of this quantifying return on investment for live virtual constructive is kind of like my wife's honey-do list for me. It's, you think you got the nut cracked, and it spawns off 4 more things that you got to do. And Captain Loeffler, you kind of articulated some of the next steps and some of the spin-off research that this is creating. But I wanted to ask Jeff, your team, what are next steps? What's next for this data that you've created? what are the next steps for your team? And if there's an ask of industry players that are on the call here, what would you like them to do? Where do you need help, or where do you want to take this study, and who do you think could help you with that?
Yeah, that's a great question. So, I mean, at the so APL, for folks that don't know, we're a Department of Defense University affiliated research center. So we work as a trusted advisor for the government. And so, what we're trying to do is take this approach and this methodology and work with some of our other sponsors and the other services to, help them, look at the problems in similar ways and see if we can leverage what we've developed here to help them with some of their problems. And I think things are going to get interesting because, especially you look at what we talked about early on in this presentation with the Marine Corps' Force Design 2030 and this desire to be part of the integrated naval expeditionary force. There's going to be much more emphasis on integrated naval training. So both Marine Corps and the Navy. So how do we apply what we've done here to that greater problem set that now involves, not only ground forces and air forces and the command element and the logistics element, but now you have naval elements that are involved in it and naval aviation. So much more complex. And the mission space is changing too as the Marine Corps, starts implementing their concepts of expeditionary advanced space operations. It's a different way of operating. So we're going to try and apply our methodologies to dealing with that as well. How can industry help us or potentially leverage the work that we're doing? I think some of the big things are make sure that your interactions with the services deal with both the requirements setters, the acquisition organizations, as well as the operating forces, those that are going to use your capabilities, to understand everybody's full set of priorities and what's most important to them. And then I think what Captain Loeffman talked about, moving more to an agile approach, build a little, experiment a little, test a little with the users and work in that collaborative manner with them to better see if your solutions are meeting their needs and adapt them rapidly is going to be key.
Awesome, thank you. So my advice to industry that's on the call is start thinking about how to talk about return on investment and how readiness is impacted in the longer term. So that better prepares you to have those conversations with folks like Jeff and Captain Loeffler that are trying to look at these and make big business decisions and big bets on the technology that you're providing. So with that, I'm going to say thank you, gentlemen, for the discussion today, and thank you everybody for joining us. We appreciate you being here, and again, this I think is one of those longer term discussions that will continue, and maybe we'll see a part 2 here shortly with these guys on the next round and some of the achievements that we see over the next year. So again, thank you very much, Tim. Thank you for co-hosting and in watching the chat and answering the questions for us. And thank you very much to NTSA for sponsoring this event with us. And we'll catch you next time in the next one for July. We look forward to seeing you all then. Thanks.